Okay, so we're swapping out the jaws here on my lathe. So these are special made jaws. Company makes these. These are for holding car sleeves. So you can turn sleeves down. I modified them and I use them for cutting Harley cylinders down. So I can, whatever you want to turn, it holds the cylinder off the bore, so everything's concentric, and you can face it off, shorten it, cut fins, whatever you want to do. In this case, we're going to trim the spigot back around again. So it's just a matter of unscrewing them. These have removable jaws on my chuck, so you need that kind of a chuck for this system to work, obviously. It's just a matter of unscrewing them. Allen bolts out of here. Swapping them over. These are numbered, so you got to put them back in the same spot. Things have to be clean, otherwise it doesn't work right either. So I won't clean my lathe, but I will clean my lathe chuck. I have my priorities. If it makes it more accurate, I do it. Otherwise, I don't care. Okay, so those are all tightened up now. There you go. Now these have been turned so that when they're when you put the cylinder on here, they're concentric and straight to my chuck. And they're made to have more tension on this outside edge than the inside. So as you tighten these up, you get about equal pressure across the length because it starts out hitting here first, and then as you tighten it up, the jaw actually flexes down from force, and it equalizes the pressure on the cylinder bore. It has a nice flat surface here, or a curve that matches the bore, so it doesn't scrape up your cylinder. So if you do it right, you don't have to refinish it. Now, the other three jaws I don't hit on. They're back here, so they don't hurt anything by being there. All they are is a stop plate. They come up and bump against it, like that. So it gives you a nice even stop. Alright, so we need to find out how bad this thing is. Cut it, that's good. So let's see how concentric everything is. Now this setup is not 100% even, but it's pretty close. Does a good job of centering. Okay, so too much on there. Okay. Looking the back side of my tripod's in the way. Okay, so got our dial indicator on here, see? So as it goes up, the number goes down. As it goes down, the number will go up. Can make sure you don't hit nothing. Especially when this cutout comes around, you want to make sure you don't hit on that. Okay, so let's see what we got here. That one bad spot right here is really bad. It's way high right on this side, which is not where it's supposed to be high. And you go from extreme right here to extreme right there. 90-degree turn is our maximum air. This is where our big problem area is, right here. This is the massive amount. This is where the problem's at. So, is it me, or is it the cylinder's bad like that? Right dead center of that is our worst spot. So the way you check the accuracy of your tooling is make a change, see what happens. So easy to turn it 180 degrees is a good test. Didn't move anything else, so let's see how accurate my tooling is. This is our worst spot. Worst spot again. It repeats. So I turned it 180 degrees, so that would be the bad. If I had a problem, I set up my lathe, the bad spot would have been down here. It stayed in the same spot even though I turned 180, so that means the cylinder's bad. It's not my tooling. That's how you check stuff. So the high spot is here. That's our worst spot right there, high. And our worst low spot is right here. So this corner is what moved, and it moved outward. Because we're going up. Nope, that's down. Okay, as it goes up this way, that's low. So this is a low spot. So what happened on this corner? That is the corner that is now missing. Okay. See right here? This is our problem area. So this is pretty thick over here in the case, so it didn't move much. This is our thin area. This is the problem with the cylinder was at right here. So this stud was mounted hard and the cylinder was trying to do something, or the case was trying to do something and the cylinder held it. It's probably more what happened. Because all you got is this one bolt here left, everything else is gone. So if this bolt pulled the thread slightly, the cylinder was trying to retain it. When the case went sideways, it buckled the cylinder pretty bad, would be my guess. That's the spot right there that's on that corner. See, this is where the center of this case is. This is our bad spot. So that's where all the stress was at, and that's where the cylinder showing all the stress was put into it. So there you go. So that's how you identify areas. So the problem is not the cylinder's out around oval shaped one way. The problem is this whole corner is screwed up. This is the problem. High to low is right here. Boom. So we're gonna go ahead and turn it, cut it down a little bit the size, and then that'll cut away the bad corner and not affect the other spots. And that should true things up a little bit. Maybe I'll bolt it onto the case then. It'll also take the stress out of the cylinder a little bit. Now, more than likely, this surface here is probably out of whack too, I bet. Which probably wouldn't hurt to be surfaced. I didn't check that with the over there to see if that's true, but my guess is it probably is out of whack. And I can check it pretty easily by doing it this method. Okay, we zero out the indicator there. We move this in until it just touches. And see, we're at 0. Back it up a little bit. Go to our bad area. See the difference? It's 2.5 to different. Go over here. I have to check on that spot. Only one out. Ooh, that's low, look at that. So that spot's way bad. You know, these cylinders didn't come off that damn motor. I keep forgetting that. These cylinders did not come off that motor. See, I'm putting them on the motor, so I keep thinking it's part of the motor, but it's not. These did not come from this motor. These came off one of Wink's motors. So, Alright, so our surfaces are definitely not 100% true. So this whole thing moves around a little bit. So this whole cylinder is just way the hell out of whack, no matter what you do. Now I have no way of measuring this side to see how bad it is. But we are seeing this as being different. Okay, so what I'm going to do, I'm going to standardize where I have the cylinder at. So when I come back to machine these later, I'm going to have to remachine these cylinders, but not right now. Where's my number 1 position at? I'm going to put this back over here, my number 1. This way I can repeat. So here's my number 1. I'll put that right on the right side, as usually I do. So now I can take this cylinder in and out of the lathe and put it back in the same spot. So I can do this side, I can flip it around 180 and do the same side. And re-true up all these surfaces later on. Like I said, right now we're in mock-up stage, we're not in remachining everything stage. So that one is 3 thou low. 3 thou low. 0. 2 thou low, so about 1.5 thou low. So right now we are 3 thou would clean this whole surface up, so get it smooth and even. So I'm going to have to come back and double check all this stuff later. Alright, so for now I'm just going to clean up the cylinder spigot enough I can use it. And we'll leave it at that for now. That's the uneven spigot you're here, or the flange. I'm going to go until I hit the spigot. Should slow this down a little bit. These are probably fairly hard material. We're hauling ass here. Probably cut faster than that though. That's right. Hitting right there. Cutting a little bit more than I want to there. Back it off a little bit. Still a lot more than I wanted to. Damn. Worse, not better. Got more than I wanted to, but oh well. be a lot rounder anyway. The only place it didn't clean was from here to here. Yeah, I definitely cut a lot more than I wanted to. Well, it's cut. It's there now. Okay, let's see. We want to get down to 5. And we are way the hell under 5 now. I can measure better over here. Yeah. Cut about 8 thou more than I wanted to. Oh, I keep hitting on that corner. There we go. Yeah. No, not really. That's about 5 more. We're at 22. I wanted to be up around 3 here. So, about 5 thou less than I wanted to be. Yeah, close enough. I'm going to cut more on the inside, which I really didn't want to do. There's another 5 or 6 more on that side. But impact mark in there. Like sharp edges. All right. Should be able to put this into the motor now. Go this direction. That should fit. Let's go find out. I'd be shocked if it didn't go on now because I cut a lot off. Let's see here. Put that over here. Yeah, it fits now. Get clearance. Alright. At least now we can mark the motor up. So it's a little looser than I want it to be. Oh well, shit happens. When you have a tight fit, 5 thou is a big difference. Where's the low spot? This is all low through here. Start cutting over here. About there. Yeah. About 8 thou. Okay, well it's got clearance now, that's for sure. Okay, so now the case I can actually bolt it together. So I'm going to get this cleaned up. We'll be back.